Hello everyone, I am Mohammad Hassan from the Department of AAML, currently pursuing my career at Savita Engineering College. So I am here to explain you or walk you through what is Siamese networks and how we are implementing it in question duplicates. So let's get to the objective first. So number one, the objective of the experiment. So the main goal of this experiment is to use CME's networks to identify whether the two given questions are duplicates or not. This is a common problem in natural language processing that can help reduce the redundancy on question answering platforms like Quora, etc. So basically redundancy is duplication data or duplicated data. If we remove it, it will be very effective in reducing the size of the data, which makes it easier and efficient for computational time reduction. So yeah, by identifying the duplicate questions, we can merge similar content and improve the search results and enhance our content and the user experience. So yeah. So what are the key challenges we will be facing here will be semantic understanding. Semantic in the sense understanding of the relationship between the words or the sentences. So the questions may be semantically similar but phrased differently. Text, textual variations. Variation in text, choice, structure, and grammar can make the task challenging for traditional models. That is, that may also include the parts of speech in the consideration of grammar. So to solve this, we use a CMS network architecture that compares the two questions and predicts whether they are duplicates or not. A CMS network consists of two identical neural networks that share the same weights. It learns to identify the similarity between the inputs pairs by mapping them to a common feature space. So second, so let us also side by side walk through it with a block of code. So it will be helpful in visualization and understanding of the CMS networks. So yeah, the first part in the code will be importing the data. So yeah, part 1 will be importing the data. You can use NumPy or Pandas to convert it into a data frame and load the CSV file. So yeah, here they have used the questions.csv to import the file and they are just printing out the question pairs. So yeah, they are also splitting the given data and also turning them into text vectors. So yeah, so the part 2 can be defined as defining the CMS model or the program implementation. So firstly, you will have to pre-process the data. Pre-process in the sense, load the data, clean the data, embed it. So yeah, the second step in part 2 would be embedding layer, which converts the questions into a dense layer using embeddings. We can use by LSTM learning. Sorry, BISM layer, which stands for bidirectional long short-term memory. It accesses the sentence or the text in two different ways, that is left to right and right to left. Using this, we can analyze the current words preceding and succeeding term and analyze if there is a pun or a not. Pun in the sense the word could have same meaning or different meaning. So if you can take a example of New York City. Taking the current word as York, it could be used as a succeeding term, that is city, and the preceding term as new. New could act as two different verbs, and York could act as two different words. But here, with the help of the preceding and succeeding term, we can decide it is a New York City, that is a location, for NER, that is named entity recognition. So distance calculation. Compute the Euclidean distance or cosine distance between the output layers to measure the similarity. That is, the cosine similarity can also be used to check the similarity constraint. It can be found using the dot product divided by the product of the norm vectors. The cosine similarity value lies between 0 to 1, whereas the higher the value, the more similar they are. So let's get to part 3, which will be training. So yeah, part 3, training. Training the model. Splitting the data into training and test dataset, we'll use cross-drop entropy loss and monitor its performance and validation state. Dividing the sets into validation and training set or the estimation set helps us in cross-validation. Cross-validation in the sense We'll divide the given dataset into different halves or n number of halves and check it based on the unseen data. We'll train it based on certain amount of training dataset, and we'll split some of the data or reserve the data for some unseen data, and we'll evaluate it based on that. This set is known as validation set, and we use this cross-validation method to evaluate the model's performance on unseen data and analyze its underfitting conditions, overfitting conditions, and etc. And we could improvise on its generalization, etc. Yeah. So we can execute based on the input and output data and compare its output accuracy, that will be X%, comparing with to the probabilities. So yeah, lastly, let's get into the applications of MLP, that is multi-layer perceptron. In this experiment, in the Siamese network architecture, the final layer is a MLP. With the sigmoid activation function, it combines the distance calculation from the two LSTM outputs and predicts the probability of the questions being duplicates. So the general applications of MLP would be binary classification. As seen here, MLP can predict whether the given pair of questions are duplicates or not. So they can also be used for sentimental analysis in MLP, which is classifying text based on sentiment. It could be positive sentence, it could be a neutral sentence, it could be a negative sentence. And some other examples are spam detection in mail, which could be lead to fraud, theft, etc. And also image recognition, that is detecting objects inside a specific image. MLP can serve as a classifier in image recognition task after feature extracting in CNNs. So that's it for this part of MLP and implementation of CMS networks in question duplicates. Thank you.